In this video, we will be making this simple project where you can move a step motor using 2 push buttons. A little while ago, I posted this video here. I lost a code to this video and have had some viewers ask where the code is. I wish to tell you that I've remade this code after spending a few minutes messing with some examples from Arduino IDE. Something to note is that this specific step motor requires 2048 steps to make one 360-degree rotation. The amount of steps depends on the stepper motor, so you may have to go and search for a specification sheet about your stepper motor if you're unsure. Knowing this information is important and is required for this project. Before we begin with the wiring, I made this schematic here if you wish to use this rather than following along. You can find a link to this image in the description, same for the code. For this project, we're going to need an Arduino board. I'm using an Uno, but you can use whatever you want. We'll also be using a breadboard to keep the wires more organised, 2 push buttons, a step motor. I'll be using the 28BYJ-48, which came with one of my kits, a stepper motor drive board. I'll be using the ULN 2003, which came with my stepper motor, and a bunch of jump lead wires to connect everything together. With that all said, let's begin. We will begin by connecting 5V and GND to the breadboard to allow the step motor and buttons to connect to the power, rather than running out of power on the Arduino since we have 2 5V ports and one 3.3V port. From here, we want to connect the 2 push buttons. I'm using limit switches, but you can use whatever push button you want. As long as you can join 2 connections together and Arduino knows you're pushing a button, that's all that matters. For these limit switches, we have the signal wire at the back, the middle being VCC, and the last one at the front being GND. The first button will connect to pin 13, and the second button will connect to pin 12. After connecting the buttons, we will connect the stepper motor drive board, which has 6 pins. 2 of which are power, and the other 4 are the stepper motor control pins. The first pin is in A, which will connect to pin 7. The next pin is in B, which will connect to pin 8, in C, which will connect to pin 9, and in D, which will connect to pin 10. The final 2 pins are for power, so they connect to VCC and GND on the breadboard. Now that everything is wired up, let's head over to the coding site and take a look at this code, since that's what we're here for. On the first line, we import the stepper library. We do this so it makes it easier for us to work with the stepper motor, rather than having to write it all out ourselves. Then we have 3 integer variables. The first variable is assigning the number 13 to the name button 1. The next variable is assigning the number 12 to the name button 2. And finally, the final variable is assigning the number 2048 to the name steps. The first 2 variables we'll be using to set up the pin mode, which defines what pin will be an input or output on the Arduino board. The last variable, which is named steps, will be used in the code to define how many steps it takes for the stepper motor to complete one rotation. After the variables, we have the stepper class, which we'll be using to define the stepper motor. We create a name for our stepper motor. I'm using stepper as it seems appropriate. Then within this, we have the steps and a specific order of the pin input. Pin 7 for in A, pin 9 for in C, pin 8 for in B, and pin 10 for in D. I'm using this order as it works for the 28BYJ-48 stepper motor. You can find the order that works for your stepper motor by searching for it online. If yours doesn't show up, that poses a rather big problem. After inputting the required libraries and defining the variables, we have the void setup, which is used to declare pin modes, serial output, etc. This will only run once. Within the body of this function, we have 2 pin modes, which is where we declare that button 1 will be an input and the same for button 2. Below these 2 lines, we set the RPM for the stepper motor. I'm using 14 RPM, but 18 RPM also works. I tried 19 RPM, but it caused the motor to not move in one direction, so I changed it back to 14. After the void setup, we have the void loop. This function will run forever, unlike the void setup, which only runs once at the very start. Within the void loop, we have an if statement. The condition we are checking is if the digital read of button 1 is high. We're not using any comparisons here, as it should either be true or false if the button is being pressed or not. So when button 1 is pressed, the body of the if statement will be executed. Within the body of the if statement, we are making the stepper motor move one step, which should be in the clockwise direction, but it may also be in the counterclockwise direction. I'm honestly not too sure about which direction it will be in. After the if statement, we have an else if, which is where we're checking if the digital rate of button 2 is high or low, just like with button 1 in the if statement. If button 2 is being pressed, the body of the else if will be executed, so the condition would be true. The code within the body of the else if is to make the stepper motor move -1 steps. As I mentioned before, it may be clockwise or counterclockwise. You may have to change these around if they are backwards, but that isn't all that hard. Let's upload the code to the Arduino board and see if it works. To upload the code, we will use Arduino IDE, where we will select the port, board, and then upload the code. If we press the first button, the motor should move in the clockwise direction. And if we press the second button, the motor should move in the counterclockwise direction. And if we press no button, the motor should not move at all. Everything seems to be working as expected, which is good to see. Well, that's the end of this video. I hope you enjoyed this video, and I'll see you back, hopefully, for another one sometime soon.